Here I'm going to explain you the very basic phenomenon called diffraction. Diffraction is the bending of a wave near an obstacle. You already know this part, that's why I'm just explaining this to you now. So, maximum diffraction occurs when the wavelength is equals to the what? Nearly equals to the wavelength is nearly equals to what? The obstacle, length of the obstacle, that is the D. Here is this an opening. You can see this bend away from here to both the directions and disperse like in this type of manner, right? So for inward bending for the obstacle, that was an opening. There is an inward bend. You can see that the arrow is there. See? Now many waves from the left hand side like this, right hand side like this, they interfere with each other and makes different patterns. You just need to draw it and only. No more questions will be asked. Just draw and remember one thing: what when the gap is nearly equals to the wavelength, there is the maximum displacement, the maximum dispersion, right? Okay, now single slit interference. In the Edexcel curriculum, you will learn the Huygens principle later. Reason behind single slit interference is Huygens principle. Each point is a new what source for new waves in any wavefront. This wavefront acts as multiple generators. Now see the blue colored one. That's the central maxima. All the points join up with here with constructive interference. That is the central maxima. Right. In the same way, for the next one, you will see interfere with each other and create some dark space. That is called first order what? Minima. Now see again constructive interference. First order what? Maxima. Like that, it keep continuing. You get the what? Change of color like this. See, central maximum, maximum brightness, all the waves interfere. See the first one, first order minimum, very dark because destructively interfere. Next one, constructively interfere. Again, constructively, destructive, constructive, destructive, constructive. The pattern, see. I max, I minimum, I max 2, I minimum 2, I max 3. Like that, you can represent this data. See, you will get this type of pattern. All thanks to what? Huygens principle and the interference. You don't want to know this much detail, but I explain. If there is anybody who is very curious about this, now you have an idea how the heck what single slit works, right? Single slit works. Now you have a clear idea about that. Let me explain you the double slit. Okay, double slit interference. The structure is something like this. You have to make a skip source and make a single slit here. X is the single slit. Single slit. And there is a double slit here. Double slit. And the diffraction grating is also in the same manner. There are multiple of these type of openings. That's what the difference in the grating. I only take only a double slit here to explain you the process. Actually, you don't want to know the process. And there are 2 points like A and B, and final destination is C, first order maximum. Let's see how does it occur. Now have a really good look at. Actually, you don't want to know this knowledge, but I'm just explaining for your curiosity. Some of the students don't like to learn things like the messy. They need to know the real reason. Almost thankfully, most of my students are like that. I'm really happy for that. Okay. Now have a look at the other one. Travels in the same manner. Now the hardest part. Oh, thankfully, okay. Now both the waves, you can see that here in this point interfere with each other. What way? Constructively. This whole length I can consider like what? LA. This whole length together can be considered like what? LB. But until to here, I can cancel off this whole length. Why? This line is extremely coherent, right? If this XA, LXA is equals to LXB, no difference has changed here. LXA is equals to LXB. But from here, LA dash, and for this length, LB dash. Now from this point onward, there is a real difference. Now I'm going to draw one certain line to make this equally separated. Now this is where it is, and there is a delta L difference. Now this length, LA dash and LB double dash. LB double dash equal to LA dash equals to LB double dash. Okay. Let me explain you how the constructive interference works here. Now see the difference. Delta L equals to LB minus LA. Okay, this is the path length difference. And there is an angle with the horizontal with the point of first maxima, order of maxima take place. Now let me extend this line a bit. This perpendicular normal a bit. You will see there is an angle of pi here. This pi and this pi exactly identical. So this axis is perpendicular now. What is this angle now? It is 90 minus theta. Right? That is 90 minus theta. And if this angle is 90, what is this angle now? It's going to be theta here, theta, right? That's 90 degree now. Okay. Now let me explain you this by using very simple diagram. You don't want to know this one, huh? This is T and this is theta. Okay. According to sine theta equals to delta L over T. I'll use simple D. Sorry. Simple D. Okay. Now what is the path length difference equals to D sine theta, isn't that? And for constructive interference, there are certain number of waves being exchanged additionally. Additionally, with whole length. What is the delta L now? For constructive interference, we learned earlier n times lambda. So the path length difference here is nothing other than for the constructive interference n lambda. Now your equation you get what? N lambda equals to D sine theta. Very simple equation that you can obtain. Got it? Absolutely, you have to worry about nothing for here. No derivation is for your level, but this is only for your curiosity. And if you get something learned, please subscribe to my channel,